On Unit 10, basically when we're condensing a logarithm, just realize you are writing it, I'm going to do it all in one step but talk you through it, you are writing it as log base b. They're all log base b, and since there's minuses in here, we are going to have a fraction. Not two different fractions, just one. The first one, we take them, the factors out front, and rewrite them as exponents. So r cubed is definitely going to be on top, okay? But then do you see that we have a minus? As soon as we have a minus, the easiest way we can tell you is the minus is going to go to the denominator. So since there's 1/3, that's going to make it actually the third root of p, and that goes to the bottom because there's a minus. So this becomes the third root of p down in the denominator. And then we have a plus sign. So whenever we have a plus sign, we go back up top. So the 5 makes it t to the 5th, and that's going to be on in the numerator. Minus brings it back down, and then the 1/5 makes it the 5th root of w. So this would be like that. Just think about how you would do this problem the other way and expanding it, and I think that'll make sense there. Okay, so likewise here, we have log base x. Okay, log base x, and we're going to have a fraction. So this is going to be h squared on top when we bring the 2 up. 1/4, k to the 1/4 is going to be the 4th root, but it's on top because there's a plus sign. So I leave that one right up here, 4th root of k. And then there's a minus, so the m to the 4th power goes down. And again, these get written as exponents. Okay, so now down here, we're going the other way. So we're going to have to see log base 2 written 3 times here. So this is going to be 3. Again, I'm going to show you all in one step. 3 log base 2 of r, because the power comes out front. We have multiplication, so we're going to change that into addition. The 1/3 comes out front, and we have to write log base 2 of t again. And since this is in the denominator, that means it's a minus sign, so minus 5 log base, 2 we're doing of p. Okay? And then this one likewise is going to be log base 5 of x. Nothing else multiplied, so no plus sign, so minus, and we'll have a 1/2 log base 5 of y because it's the square root, so square root is the 1/2 power, which comes out front, and then we'll have minus, since it's in the denominator, we have a minus sign, not a plus. Those are, I know you think those are multiplied together, but it's the entire fraction, so it makes it a minus sign. So we have log base 5 of, what is that, z, and I forgot to write my 5 out front, so 5 would be there. Okay, cruising along with Unit 10 here. Now we're going to solve these, okay? So we got to use these properties to solve. So, you know, we can drop logs whenever we have logs on both sides, or else we're converting to exponential form. So this one's unique in the fact that we can make it natural log of x times x minus 2 equals 8. Well, we cannot drop the logs here because we don't have a log on this side. We can't get rid of those logs. So what we do is convert to exponential form. So that would be e to the 8 power equals, and then we have x squared minus 2x. This is base e, so I just converted to exponential. So this isn't going to be beautiful, but I can make this a 0. I could go x squared minus 2x, and then minus e to the 8th power. Well, my instincts here are to solve by factoring, but I'm not going to be able to find those factors. So I'm going to go to the calculator here, and if I go to a calculator page, I should be able to go to algebra class, polytools, and find the roots of a polynomial. So it is a degree 2. Let's see what I got here. I can't remember, so let me move this. All right, so my a value in standard form is 1. Then I have negative 2. And then I'm going to type in negative e raised to the 8th power. I'm going to close off my parenthesis, and I'm going to hit OK. They're saying, do you want to solve this? I sure do. So I hit enter. Boom. And then I got 2 answers. I got x is approximately negative 53.61, and what is that, 55.61. But if we look back up in our problem, remember we cannot take log base e of a negative number, so that answer will definitely get rejected, and we'll go with this one. Okay, now this problem here is going to be very similar, but log base 2. So we've got log base 2, and then the x is over the x plus 3. because we have a minus sign. Subtraction turns into division as a single log. So that equals 3. Cannot drop the logs, so we convert to exponential form. 2 to the third power. So I got 8 equals, and then we got, what's that going to be? X over x plus 3. So then we just go through solving. Multiply by x plus 3 to both sides. Distribute. We're going to have 8x plus 24 equals x. And then we're going to go up here and get, what is that going to be? 24 equals negative 7x. Divide by negative 7. This, but we can't have a negative because of here. So we're going to say no real solution to this problem here. All right, cruising right along, solve another one. Now we're going to have logs on both sides. So basically you have log base 10, but the base really doesn't matter as long as they're all the same, because we're going to end up just getting rid of the logs. All right, because logically, if we have log of something equal to log of something else, and they're both in the same base, that means this thing here has to be equal to that. So we just solve that problem. So 3 plus x over 2x plus 1 is equal to 4. Okay, here we go, solving through that. 2x plus 1, cancel, cancel. Multiply this side by it. So we're getting 3 plus x equals 8x plus 4. Subtract, we're getting 7x equals, what is this, negative 1. So we're getting an x value of negative 1/7. Make sure I did that right there. Yeah, that's a 7, negative 1/7. So then we're like, oh, negatives, got to reject them. Not necessarily. Look up here, 3 plus a negative 1/7, that'll still be a negative number. If we double negative 1/7, that's negative 2/7, which plus 1 is still a positive number. So that's actually okay. That answer is all right. All right, then looking here, again, we can drop the logs on this problem. So I'm going to speed up that process and say x minus 4 over x plus 5, because we would write that as one log with division, is going to be equal to 6 since we have it on both sides. So now I'm going to get the x minus 4 equals 6x plus 30 when I multiply the x plus 5 to both sides. So bring this over, we'll get ourselves a negative 5x equals, add the 4, 34. And then we got x equals negative 34/5. Well, 5 goes into there. It's going to be like 6 point something, right? Negative 6 point something. So when I plug that in right here, negative 6 point something plus 5, that's not going to be, it's not going to work out. So we're actually going to get no solution to that one as well. All right, I'm going to stop the video here and we'll pick up next time.